here to discuss the Hamiltonian circuits. So a Hamiltonian circuit is a path that uses each vertex of a graph exactly once. A graph that contains a Hamiltonian circuit is called Hamiltonian.
Go.
That contains a Hamiltonian circuit is called Hamiltonian. Unfortunately, we do not have a straightforward criterion to guarantee that a graph is Hamiltonian, but we do have the following Hubbell theorem. This theorem is called Dirac's theorem. So consider a connected graph with at least 3 vertices and no multiple edges. Let n be the number of vertices and the graph. If every vertex has degree of at least n over 2, then the graph must be Hamiltonian.
Go.
So let's apply the Dirac's theorem. The graph below shows the available flights of a popular airline. An edge between two vertices in the graph means that the airline has direct flights between the two corresponding cities. Apply Dirac's theorem to verify that the following graph is Hamiltonian. Then find the Hamiltonian circuit. What does the Hamiltonian circuit represent in terms of flights? So in this graph, there are 6 cities: Portland, Boise, Salt Lake City, Reno, and Sacramento. There are 6 vertices in the graph, so n equals 6, and every vertex has a degree of at least 3. So 6 divided 2 equals 3. So by Dirac's theorem, the graph is Hamiltonian. This means that the graph contains a circuit that visits each vertex once and returns to the starting vertex without visiting any vertex twice. By trial and error, one Hamiltonian circuit is Portland to Boise to Bots to Salt Lake City, and to Reno, then Sacramento, which represents a sequence of flights that visits each city and returns to the starting city without visiting any city twice.
Go.
So next example, a large law firm has offices in 7 major cities. The firm has overnight document deliveries scheduled every day between certain offices. In the graph below, an edge between vertices indicates that there is a delivery service between the corresponding offices. Use Dirac's theorem to answer the following question. Using the law firm's existing delivery service, is it possible to route a document to all the offices and return to the document its originating office without sending it through the same office twice? So in this graph, it's not necessary to use the Dirac's theorem because looking at this graph, we can identify one.
Go.
So in this graph, it's not necessary to use Dirac's theorem because looking at this graph, we can identify Hamiltonian, which is Hamiltonian. It's not necessary to use all the edges as long as you visit all the vertices without repeating.
Is the weighted graphs. A Hamiltonian circuit can identify a route that visits all the cities represented on a graph. A weighted graph is a graph in which each edge is associated with a value called a weight. Find Hamiltonian circuits in a weighted. So this is the example. Begin by letting each city be represented by a vertex. Draw an edge between 2 vertices if there is a flight between the corresponding cities, and label each edge with weight that represents the number of miles between the 2 cities. So let us plot this into this. So the Chicago and New York 713, Chicago and Washington 597, Chicago and Philadelphia 665, and Chicago to Atlanta 585, and then Chicago to Dallas 803. And then New York to Chicago 713, it is similar. So this is the graph. So this number are the weight of every cities. So Hamiltonian circuit. So we find 3 roots in this graph. Beginning at Chicago, one such circuit is Chicago, New York, Dallas, Philadelphia, Atlanta, Washington, then go back to Chicago. By adding the weights of each edge in the circuit, we see that the total number of miles traveled is 713, 1,374 plus 1,299 plus 670 plus 544 plus 597 is equal to 5,197. So by trial and error, we can identify 2 additional routes. Next is the Chicago, Philadelphia, Dallas, Washington, Atlanta, New York, and then go back to Chicago. The total weight of the circuit is 665 plus 1,299 plus 1,185 plus 544 plus 748 and then plus 1,713 and then is equal to 5,154. And the third route is Chicago to Washington, Washington to Dallas to New York, Atlanta, Philadelphia, and then go back to Chicago. The total mileage is 597 plus 1,185 plus 1,374 plus 748 plus 670 plus 665 is equal to 5,239. So therefore, the difference between Hamiltonian and Eulerian is it can repeat the vertices without repeating the edges. While the Hamiltonian, it is not necessary to cross all the edges as long as we visit all the vertices without repeating.
Would be all. Thank you.